So can you tell me what is the answer for this? Show that the signum function f map from R to R given by f of x is equal to 1 if x is greater than 0, 0 if x is equal to 0, 1 if x is less than 0 is neither 1, 1 nor onto. See, signum function's definition is already given here. It's a many to one function. Why? Because when you substitute any positive value of x, right? When you substitute any positive value of x, the answer is always going to be 1, right? X is equal to 0, it is 0. When you substitute any negative value of x, the value is going to be 1 again. Actually, it should be minus 1. There's a mistake here. So the graph for this will look like this. So here, where will be the point of discontinuity? Look at it, no, you will be able to see at 0. So here it will be an open circle, here it will be an open circle. So this function is neither, okay, it's not 1, 1. I hope that is clear because it's many to 1. What about onto? So you see the codomain set, you have real numbers, but what is the range set? Minus 1, 0 and 1, right? Except those three elements, the other elements do not have a pre-image associated. That's it. So this place you need to put a big dot like this. Means this value is actually the function value. Because x is equal to 0, what is the function value? 0. Clear? Shall I proceed? No. A is equal to 1, 2, 3, B is equal to 4, 5, 6, 7. Let f is equal to 1, 4, 2, 5, 3, 6 be a function from A to B. Show that f is 1, 1. Is it 1, 1? Because no two elements in the range set are the same. Right? Hence, it's a 1, 1 function. Then what about, oh, we have to show that f is 1, 1. How will you show? That's the same logic. No, since each element is associated with a unique output, it's a 1, 1 function. 1 minute. So check the solution. So that's the thing they have given. Each input has a distinct output. Right? You're copying it. Huh? You're reading it. Okay. Are you clear with this? Yeah. So it is seen that the images of distinct elements of A under F are distinct. That is the reason. Hence it's 1, 1. Simple. Okay. There is nothing much to prove. What about the seventh one? In each of the following cases, state whether the function is 1, 1, onto, or bijective. First one is bijective. Okay. So how to do that? You will say f of x1 is equal to f of x2. So 3 minus 4x1 is equal to 3 minus 4x2. 3 and 3 will get cancelled. X1 will be equal to x2. Okay. Then what about the range? Y is equal to, sorry, onto function. Y is equal to 3 minus 4x. X will be equal to 3 minus y by 4. Right. So for every real number that you substitute here, are you getting a real number? Yes. So how to find that is, you know, I'll just give you another hint, okay? See if at all you're not able to see. I just wanted to extend this concept. This part is clear. Please confirm. When you substitute the value of y as a real number, you're getting a real number. That is one way. Check the domain of this function. So you know how to check the domain of a rational function? See, for example, if I have x divided by 2 minus 3x. For example, I have a rational function like this. 2 2 minus 3x should not be equal to, so x should not be equal to 2 by 3. So what will be the value you will write? So you will write r minus of 2 by 3. Am I right? So using the same logic, if this value had it been in the denominator, you need to apply that logic. But whereas if this value, like you have the function, right, in the numerator itself, sorry, the expression in the numerator itself, then it will take r values. Because we didn't speak anything about this x, did we? We spoke only about one thing. What is it? The denominator should not be 0. So find those values that give you the answer. Why I'm telling is, suppose had the question been like this, and when you're solving, right, you get x is equal to 4 divided by 3 minus y. Will it be an onto function? Why? Because what is the codomain set? Real number, but which element from the codomain set will not have a pre-image? 0 kadayadu. 3 will not have. Because 3 minus y should not be equal to 0. Y should not be equal to 3, meaning r minus 3. The meaning of it is, whatever real number you keep plugging into it, you will get all the real numbers except 3. So the codomain is not exhausted, hence it will not be an onto function. Are you able to understand the difference? It's a minor point, but concentrate on it. Yes, sir. That's a general example. It's an example. I just taught you how. So this has nothing to do with this problem. I told how to find the domain of it. Am I clear? Please make a note of it. That's it. You solve this exercise, sir. முடிச்சிட்டியா? எவ்வளோ முடிச்ச? அடுத்து நீ அப்படியே பண்ணிட்டே இரு. Don't wait for me. You keep doing it. So those who have completed, keep doing it. Shall I proceed? We have another problem on this, no? This one. F is a function map from real number to real number. F of x is equal to 1 plus x square. Is this a 1-1 function? No. See, mostly if you see a quadratic function, right, or a quadratic polynomial, it will not be a 1-1 function because it takes the shape of a parabola. It will either take the shape of an upward parabola or a downward parabola. What shape will it take here? Why? Coefficient of x square is positive. If I ask you to draw the graph, how is it going to look